So good afternoon, everybody. Then we're going to start our algebra review day 4. This is solving systems of equations. We're going to take a look at the first two methods of doing this, which is by solving by graphing and solving by substitution. So first of all, you graph, to solve by graphing, you want to graph the equations in the system. The point of intersection is called the solution to the system. Okay, it's right here. That's the solution. Okay, because it's the point that if I substitute that point into this equation for this graph, it'll make it true. If I plug that point into this graph's equation, it will also make it true. So it's the one point that will make both equations true. All other points will only make one equation true, but not the other, right? If I plug this point into this equation, it will make this equation true, but not this one true. Okay, so it has to make both equations true. We have special cases where we have parallel lines and same lines. So one of three things are going to happen. The graph has one solution, right? You have one solution come up. That's where they intersect once. No solutions means they're parallel lines. So no solutions means we have two lines are parallel. They're never going to intersect, so they don't have any point in common. So no solutions. Okay. We also have what's called an infinite number of solutions, and that was where the two lines are basically the same line. Okay, so they sit on top of each other. Okay, they have the same slope and same y-intercept. This one down here will have the same slope right here because they're parallel, but a different y-intercept. Okay, this one has basically different slopes and different y-intercepts because they're doing completely this different thing. Okay, so let's take a look at one of these. So to graph this equation here, we first want to get it in slope-intercept form so I can graph easily. We could graph it using x and y intercepts, but sometimes this is just the easiest way to go here. So we're going to multiply everything by -1. So that will leave us with the y equals a positive 2x minus 2. So we're going to have a y-intercept down here of -2, and then a slope of 2 over 1, 2 over 1, and so forth. Okay, now I'm going to graph my line nice and neatly. Grab my line here and graph my line. Okay, then I'm going to go over to my other graph here, and we'll graph this guy. So we'll subtract 2x from each side. So we have y equals a -2x plus 6. So notice we have different y-intercepts, and we also have different slopes. Okay, one's negative, one's positive. So we're going to go up here to 1, 2, 3, 4, 5, 6. And we go down 2 over 1 this time, down 2 over 1. Down 2 over 1. So you can tell right there is our point of intersection because that's where it intersects, down 2 over 1. And then we can graph our line here. Okay, and then our point of intersection right here is right where it intersects. Okay, over 2, 2. So my point 2, 2 is my solution to my system. Okay, and that's how you solve by graphing. Okay, let's take a look at these guys. Okay, so we have a y-intercept of 5, 1, 2, 3, 4, 5, and a slope of 1/2, so up 1 over 2, up 1 over 2. We're going to graph this guy really quickly. This time we'll just graph it by hand. And what about this guy? Let's go ahead and add 1/2 x to both sides, so we get y equals 1/2 x minus 2. Notice something that we have the same slope here. Okay, actually, go ahead and circle this. Same slope here, but we have different y-intercepts. That tells me they're going to be parallel lines. Okay, because we have a different y-intercept, but we have exact same slope. So up 1 over 2, up 1 over 2. So we're going to have exact same slopes. So sometimes it's hard to see on the graph if they're parallel, because they might sometimes intersect. So that's why sometimes looking at it algebraically will tell us, oh, they have the same slope. They're never going to intersect. So in this case, we have no solutions. Okay? No solutions to this system because they will never intersect. So now let's take a look at this one. We have y-intercept of 1 and a -2 over 1 slope, -2 over 1 slope. And so we have this guy here. Okay. Right here, we're going to subtract 2x again. And notice this time we have the exact same y-intercept and slope. And so what that means is they're basically the exact same line. And so every single point we substitute here is going to give us a solution to both equations. So this is going to give us an infinite number of solutions. Okay, infinite solutions. Okay, so that's how you solve by graphing. Solving by substitution means just that. We're going to substitute something in for something else. So since y equals 3x minus 3, we're going to plug this 3x minus 3 into the other equation for x. So we're going to take that 2, and instead of putting x there, we're going to substitute, for y. Got a little ahead of myself, guys. We're going to substitute this in for y, because y equals all that. Okay, so it's going to be 2x plus 5 times, and instead of y, we're going to substitute this 3x minus 3. Okay, and it equals 19. And then now what that does for us, it gives us one variable now instead of 2, so we can actually solve for x. So 2x plus, and we're going to distribute this 5 through here. So 15x minus 15 equals 19. Add our like terms here, so 17x minus 15 equals 19. And we're going to add 15 here. 17x equals, I think this is 34. Divide by 17. And we got x equals 2. Now I've plugged that in there. Now what is our y? Okay, so we want to take, I would probably take this equation right here and find out what our y is, because it is already solved for y. So y equals 3, and then I would take times 2, and then minus 3. So y equals 6 minus 3, or y equals 3. Okay, so remember our solution is as a coordinate pair. Okay, so it's going to be 2, 3 is our solution to our equation. So that's what I want to see as the coordinate pair. Okay, and that's how you solve by using substitution. How about this guy? Let's take a look here. Oh boy, I don't know what's happening here. Here we go. No, there we go. So let's take again this value for x this time. So this time it's solved for x. So I'm going to take this and substitute it in for, this should be y. Sorry. Substitute this in for y. So I'll have 4 times, substitute in for x. I can't get my words straight tonight. So negative 2y plus 6 minus 3y equals negative 9. And we just solve for y now. So negative 8y plus 24 minus 3y equals negative 9. Combine our like terms, negative 8 and negative 3 is negative 11. Y equals negative 9. Oh, forgot my 24. Don't leave him alone. It'll be sad day. 24. Gosh, it's late on Sunday afternoon. Sure. Negative 24, negative 11y equals, was that negative 33? Divide by negative 11, and y equals 3. Okay, so we have our y. Now we got to find out what our x equals. So again, I'm going to use this equation here. So x equals negative 2, excuse me, times 3. Plus 6. So x equals negative 6 plus 6. X equals 0. Now don't freak out when that happens, guys, because 0 is a number. So that's just our coordinate, which is going to be 0 for my x and 3 for my y. That's my solution to my system. Okay? So now let's look at what happens for our infinite no solutions. If I take this y and plug it in, this guy here, and plug it in up here for this y, I'll get this 2x plus 3 times negative 2/3 x plus 5/3, okay, equals 5. Whoops, equals 5. Okay, so 2x plus, and then if I multiply this 3 through here, the 3's will cancel out, so I'll be left with just negative 2x. Plus, and 3 times 5/3 will be just 5 equals 5. This will cancel out, leaving me with just 5 equals 5. When this statement is true, that's how we have an infinite number of solutions. Okay? Now let's look at, see what happens over here when we have no solutions. So again, we're going to take this y here and substitute it for my y down here. okay? And so we have 2x plus 6 times, in this case, we're going to put now negative 1/3, x minus 4/3 equals 5. So 2x plus 6 times 1/3, 6 will go into 3 will go into 6 twice. So it's going to be negative 2x minus, and then 3 will go into 6 again twice, times negative 4 will give me a negative 8. Okay, equals 5. If you're not sure how to manipulate fractions like that, please come and see me. Okay, this cancels out. We're left with a negative 8 equals 5. When the variables drop out like that, we're left with a false statement. So negative 5 does not equal negative 8, or negative 8 does not equal 5, right? So if that's false, that means we have no solutions. Okay, and those are those special cases algebraically. Okay, so hopefully that's a little bit of a reminder of your work you did last year. We have a worksheet in Google Classroom. Be sure to show all of your work and attach it to Google Classroom, and I will see you all in class. Take care. Bye-bye.